We must work together to shape governance structures that will ensure sustainable development and protect the region, as well as the global environment. UNEP's interest in the Arctic and its commitment to it is not recent. Over the years, UNEP has worked on Arctic issues both through its programs and through its multilateral conventions, including the Convention on Persistent Organic Pollutants, the Convention on Biological Diversity, the Convention on Migratory Species, and more recently, the Minamata Convention, which was signed in Japan last year on mercury. UNEP is currently working on Arctic Agenda 2020, a program designed to develop and implement a long-term cross-sectoral program on sustainable environmental management in the Russian Arctic. UNEP's global environmental mandate and its long-standing and successful convening authority in law programs provide vehicles to help address environmental challenges in the Arctic. UNEP's governing body, made up of governments, has adopted 2 decisions, and it's important to understand that we do have the support of governments on this, specifically geared towards work in the Arctic environmental issues and collaboration with the Arctic Council. In 2003, the Governing Council requested that UNEP provide continuous assessments and early warning of emerging issues related to the Arctic environment, in particular, the impacts on the global environment. 5 years later, in 2008, the governing body of UNEP adopted a decision calling for sustainable development of the Arctic region. UNEP collaborates also with the Arctic Council as an official observer on a number of activities, not least helping indigenous peoples address issues related to short-lived climate pollutants, and by shaping a scoping study for the economics of ecosystems and biodiversity for the Arctic. Thank you again, welcome, and we look forward to exciting, productive, and hopefully forward-looking solutions. Thank you.
I sense we're having microphone problems. Would you like me to switch to this one? Is this working now? Okay. Maybe we have to speak into it.
No.
No?
Looks like there's a connection with.
Okay. Should we turn that one off and just use that one? I feel like a rock star when I hold this one, though. We're good? All right. Well, must-have microphone ready. Thank you. Dr. Brendan Kelly, would you please come to the podium and kick us off here? And you too can feel like a rock star with this microphone. Here you go. Oh, we got it, please. Whoops. Okay. We good? Take it away. Thank you.
Okay, thanks, Heather. Hang on a second here. I just closed my. I want to thank CSIS and UNEP for sponsoring this series, which I think has been very instructive for all of us. The Arctic, as we all know, is warming rapidly, something like 2 times, right, the rate of the global change. And as a consequence, snow and ice cover are diminishing on land and in the Arctic Ocean. And those changes in snow and ice are affecting ecosystems and the people who depend on them in the Arctic and outside of the Arctic as well. I don't have my slides here. Yeah.
You can read them if you want. Yeah.
Can I do yours? That'd be good. Mix it up. There we go. And to advance, I can just use the arrow, right? Okay. So last year, the White House released an Arctic research plan that spells out 7 thematic areas of effort over the next 5 years. And it's not my intent to walk you through that plan here. Instead, though, I want to focus your attention on differences in the nature of some of the changes that we're observing in the Arctic, and also challenges in how we think about these different kinds of changes. So some changes in the Arctic are essentially directional. And what you're looking at here is simply the extent of sea ice at the annual minimum in September on the y-axis there, and the year from 1900 out to a projection in 2100 on the x-axis. And all those dotted lines are 13 different climate model projections of what's going to happen to sea ice. The solid dark line kind of running through the middle is the average projection of all those 13 models. And then this other heavy line, which is actually red, maybe you can't see that, but the shorter line in the middle there, that's actually the observed record. Well, a couple of things stand out here, I think, to you, and that's that, there's a lot of variation in the predictions of different models of the rate of sea ice loss. But you also might notice that they're all tending to overestimate the amount of ice we've had in the end of the season in recent years. And that's hence the red line is dropping below the whole ensemble, we say, of models there. But you should also notice something else, and that is that all of these models are projecting ice loss. None of them are saying we're going to have increasing ice. None of them are saying it's going to level off. They're all, and in this sense, I would say this is a directional change. We know there's variation in how fast it's going to happen, but it is going to happen. We're going to continue to lose sea ice. And the impacts on human activity, I would suggest, are similarly fairly direct, and they're mostly about increased access to the Arctic Ocean. We'll say more about that in a minute. There are also impacts on the ecosystem in the Arctic, and these are a bit more complex, but still profound. And then finally, the impacts of sea ice loss on weather in low latitudes is also significant, but highly complex. So let's look at these different kinds of impacts and see how we might need to think about them a bit differently than one another. So we'll start with this issue of increased access. I think the Admiral may say more about this, so I'm not going to spend a lot of time on this, but simply to say that the increased access is going to allow expanding economic opportunities due to efficiencies in shipping and transit of cargo and to natural resource extractions. There will also be costs that will be measured in terms of increased need for search and rescue, increased national security costs, and environmental costs as well. Well, what about the ecosystem changes? So changes in ecosystems, as I say, will be pronounced, but of course they are influenced by lots of other factors, hence it's a bit more complex. But for those organisms that are specifically adapted to sea ice as a habitat, or sea ice and snow, I should say, the impacts will be rather directional. For example, polar bears depend on snow cover to excavate dens on the ice in which they rear their young. Similarly, their principal prey, ring seals, also depend on snow-covered dens for successfully rearing their young. And in fact, ring seals need something like 20 to 30 centimeters of snow on the ice in order to excavate and maintain these snow caves that are essential for rearing young. Well, it turns out that if we look at the model projections for snow cover on sea ice, on the left panel, you're seeing for the period 1981 to 2000, This little color bar in the bottom shows you snow depths in centimeters. So you're seeing you need kind of up in the green, yellows to red to have sufficient snow cover for these seals, the primary prey of polar bears, to rear their young. Over in the right panel, you're looking at the projections for the end of the century. And what you see is basically 70% of the suitable habitat will be lost by the end of the century due to the loss of ice and sufficient snow cover. Well, let's turn to this question then of the impact of diminishing sea ice on low latitude weather. And to appreciate that, I think the first thing we have to appreciate is the scale of ice loss, sort of geographically speaking. And so if you were to rank sea ice by area relative to continents, you would see it really only be second, and I'm talking about Arctic and Antarctic sea ice here, second only to Asia in area. At the same time, the area of ice in September, again, the minimal period of ice cover, is diminishing dramatically and is now, several years after this image, something like half of what it was at the beginning of our satellite record in the 1970s. So what does this mean? Well, now we need a little bit of physics, and it's simple physics. Sea ice is highly reflective, and most of the sun's energy that hits it is reflected out of the atmosphere. Ocean water, on the other hand, is quite dark and absorbs most of the sunlight energy that hits it. So as you melt sea ice, you allow more absorption of sun energy into the ocean, hence you melt more sea ice. And that's part of why the Arctic is warming twice as fast as the rest of the globe. Okay, so what happens then? We're warming up the Arctic Ocean, but not all the heat stays in the ocean. Some of that heat escapes into the atmosphere. And so now what you've done is you've taken what had been a very, very cold Arctic and relative to a relatively warm atmosphere in lower latitudes. And that difference in temperature in the atmosphere is really what drives the polar vortex, right? This band of air that sort of traps cold air in the Arctic. So as we decrease the difference between the cold air in the Arctic because it's getting warmer and lower latitude air, that turning of the jet stream begins to slow down. And the jet stream, if you imagine a river that you begin to slow down, it starts to meander. It doesn't stay on the same course. So normally the jet stream would be in more of a band along the northern hemisphere. But what you're seeing here is these meanders that we're increasingly seeing. And it's in that trough that cold air comes down and does what we're experiencing out here. It's also contributing to drought in the western United States and to other extreme climate events. There's still a lot of science to be unraveled in understanding this teleconnection between loss of sea ice and these extreme weather events. But nonetheless, that science is underway, and I think the science community is making good progress in helping us understand it. So I just end by saying the costs of climate change in terms of rising sea level that Dr. Jeffries will talk about, in terms of ecological disruptions, shifting national security needs, are sure to be quite large, and we really need strong science to be able to make good policy to understand that. Thank you.
Thank you so much, Dr. Kelly. We're going to switch slides here, and I'd invite Admiral White to come up and do his presentation. Thank you.
Go ahead. Thank you very much. Lord knows what might happen.
You should give each other.
Yeah, of course.
There we go.
Look at that. Okay. Thanks very much, Heather and CSIS, for getting this group together. It's an important time, as mentioned. And, no, we don't control the weather, so we didn't provide you all with an Arctic venue. At least we don't control it in the Navy. I'm not sure about NSA, but we won't get into them. Anyway, so as the Oceanographer, Navigator, and the head of Task Force Climate Change, we are in the process of updating our Arctic roadmap. The Navy first published its first roadmap back in 2009, when Arctic wasn't such a popular item that it is today in Washington, D.C. or elsewhere around the country. We didn't have the kind of leadership involvement, I think, that we have today. So things have changed, strategies have changed, the Arctic has changed, as Dr. Kelly mentioned. So we're taking another look at the Arctic and basically what is happening there and what we're going to do about it. So this is just a list, and most of you saw this, unfortunately, earlier, but this is a lot of the documents that have really happened in the near term, from the U.S. strategies coming out at the national level, from the President all the way down to our Department of Defense issued a DoD-wide Arctic strategy in 2013. The Navy, along with Coast Guard, the Office of Naval Intelligence, some studies boards, and then the codes within the Pentagon have taken a hard look with all this guidance, what is happening today in the Arctic, and that's why we are coming up with our own roadmap. At the same time, understand nationally an implementation plan for the National Arctic Strategy is in the work. You can see the comment there. The thing that I want to leave you with, of course, is, we understand the Arctic is a serious concern to a maritime nation, the U.S. It's a new ocean. As I like to explain to people, when you look at the budget for the U.S. military, we are the only service, and the Coast Guard's not part of the Department of Defense, so we'll leave them out. But the U.S. Navy is the only service who has a theater, an area of responsibility that's growing. So it makes sense to shrink the other services' budgets and grow ours, but other than that. So a lot of documentation is happening. So if you're going to update a roadmap, and by the way, I do understand some of you are probably saying, why does the Navy have a roadmap? I thought you navigated on nautical charts, not roadmaps. Understand that, but we have to be able to talk joint lingo, so that's why we're doing it. This is a preview of what's going to be in the updated roadmap. Some refinement of our previous objectives and missions. I'm not going to read them to you. I will point out that if you have questions about anything I talk about and you want to ask them, there are several folks in uniform here on the front row along with me. So you track them down. They're easy to spot because of their outfit, needless to say. Plus, they're younger, better looking, and smarter than me, or maybe 1 out of 3 anyway. But some key things that we're focusing on is this is what we do in oceans around the world. It's nothing really new, but the Arctic is new. The freedom of the seas, being ready to respond to a crisis. You see along the top, we are a military organization. We're always ready for war fighting first, and we operate forward, just like a lot of the navies around the world. We are America's away team, the Navy and Marine Corps team. So as you look at the Arctic as sort of a home and away theater, by the way, because we are an Arctic country, as all of you know, these missions start to come in. Maritime security, working with Coast Guard for things like search and rescue and taking care of responding to any type of contingency up there. The sea control, like we do around the world today, understanding what's going where, what could be a threat to our security and that of our allies, working with our allies. And things like projecting our security forward, as I talked about. So, and you can see at the bottom line, we're going to start to improve our capabilities in the near term, knowing that in the future we're going to have to operate up there more and more as the ice declines. Also, I want to point out that a big part of that bottom line statement is to engage interagency and international allies. And we have great relationships in the Navy with all of the Arctic Council nation navies, all of them, many of whom are represented here, as well as other navies around the world too. So I look at the Arctic as a sort of a chance to get it right the first time amongst all the militaries and political bodies. And I think thanks to the Arctic Council and leadership of the militaries as well, we're doing a pretty good job of that. I'm happy to talk about that if there's any questions. So as we update our roadmap or nautical chart, we need to take a look at what's going on in the Arctic. And this is U.S. Navy's assessment based on current models, since you saw what has happened in the past. And by the way, this was also covered in a Wall Street Journal article earlier, a couple of weeks ago. So we have to have an assessment, an unambiguous assessment of what are we going to plan toward. If you don't know where you're going, then any road will get you there, according to, I think it was the White Rabbit in Alice in Wonderland. So this is where we're going in terms of ice coverage in the Arctic, ice minimum. What we are projecting, U.S. Navy's best projection of what the ice minimum is going to look like in these coming years. Again, it's a scientific-based analysis, can go into detail offline on how we got there. This is what I told our Chief Naval Operations, Admiral Greener, to plan for. So by around 2025, we're anticipating for a couple of weeks a year a near polar route being open to be able to transit across the route. It's not that outlandish, a little bit more aggressive than what we knew back in 2009, but probably true. Again, when we start to take a look at the ice-free waters, ice-free means navigable open water. It doesn't mean there's no ice there. This is also ice minimum in the summertime. There's going to be ice in the winter for our lifetimes. But there are going to be periods when we can do a lot of operations when there's going to be a lot of traffic in the Arctic. How much traffic? Right now, less than 1% of the global traffic goes in and out of the Arctic in any given year. Even by the height of what we see mid-century and beyond, the highest numbers we can come up with is around 4%. So we're not looking at huge amounts of shipping going up there. People can argue those numbers. That's, again, a U.S. Navy assessment. So that's what we're looking at. But you can see the ice is melting. As we talked about, it's moving toward the poles. So this is our assessment that we're using to plan on. Now, you must be crazy. Some people tell me, and there's a lot of pushback. There's a lot of non-believers. Yeah, those lines are great, but is the ice really leaving? 2013 summer. Look, we're back to coverage of the Arctic. So this graphic shows you what happened, what has happened really over many years. And what you're seeing with the whiter colors is the age of the ice. You may not, I'm not sure how well you can see the resolution, see much better on the side screens. The old ice is leaving the Arctic. How fast is it leaving? And this is fact. This is not a projection. This is not a model. This is data from satellite observations and the observations of ice thickness and ice age from NOAA. It's a NOAA video. If you search hard enough on Google, you can find it. Challenge for you. That's your homework. This shows you what's happening to the old, thick ice. It's going away. Even people who don't believe the Arctic ice is melting, if I sit them in a room and starve them for 3 days and show them this video, endless amounts, they'll believe it. It is leaving. So also, this also actually justifies, I was quoted in the Wall Street Journal about a week ago, the bottom line of an article, if you saw it, and Admiral White said the ice is moving pretty fast. My wife said, you have a master's degree in oceanography and that's the best you could do? It's moving pretty fast from a global time scale here, okay? So again, our projection, not that far off, I think. Certainly arguable. So what are we doing about it? There's a lot of acronyms here. I won't bore you, but our roadmap, and we're going to, again, when you see it, when it comes online, it'll be open to the public, just like the rest of them. It's going to get into detailed action. So in the near term, between now and 2020, it's about making hard decisions, how to spend precious national resources toward a Navy in partnership with the Coast Guard and allies that can operate up in the Arctic. Looking at exchange, training, doctrine, requirements, all this stuff you have to convince somebody in the Pentagon or over on the other side of the river, this side of the river, in Capitol Hill, that it makes sense to spend money toward Arctic readiness in the future. And then the midterm, be ready, have a Navy force that is ready, and then looking past 2030 to a Navy that can operate in the Arctic when needed, just like we do in the Gulf of Mexico, the Western Pacific, the Southern Pacific, the South Atlantic today. So that's really our roadmap to get there and what it's going to take to do it. So it's not a crisis right now, although crises happen all over the world. Cruise ships in the Gulf of Mexico, for example, that sometimes people have to respond to. So we don't see the Arctic in itself as a crisis. It's an opportunity and a challenge. An opportunity to get it right amongst interagency, international partners, and we can talk about that, and a challenge because we don't have a lot of experience operating the Arctic except for our submarine fleet. So with that, thank you. Happy to take your questions, but the Navy is on board and planning to be certainly be ready for the Arctic when we're needed.
Thanks, Admiral White. Great presentation and best slides. When you research the Arctic, you come to love great maps and great slides like that. So thank you so much. Dr. Martin Jeffries has a tough job. He's got to play cleanup to two terrific presentations. Again, after Dr. Jeffries' remarks, we're going to bring everybody back up and have a little conversation on the Arctic. So Dr. Jeffries, please.
Good afternoon, everybody. And thanks to Heather and to CSIS for the invitation to be on the panel. The invitation came out of the blue, and I was quite surprised. Me? And I like the outstanding intellect, if I could have that on paper later. Thank you. You've heard a lot about sea ice, which often grabs most of the headlines about the changing Arctic, and rightly so, because the consequences of the changing ice cover are profound. What I'm going to do is say a few words about a couple of other components of the cryosphere, the world of ice, and that is permafrost and glaciers and the Greenland ice sheet. They may not get quite the headlines, but again, the consequences of changes in permafrost and in the glaciers and the Greenland ice sheet are potentially profound. And coupled with the changes in the sea ice cover and snow ice cover, these things all come together to create what's potentially a horrible critical mass. Permafrost. What I'm surprised Brendan and Admiral White didn't say much about, but they did infer or imply it, is that the changes in the sea ice cover alone indicate a lot of potential for economic development in the north, natural resources, oil, gas, minerals, fisheries, and so on. Now, anything on land, any new developments on land, any new construction on land for infrastructure that will be required if this natural resource development goes ahead is going to be a challenge. We have permafrost throughout the Arctic. Permafrost is permanently frozen ground. So ground that remains frozen year-round, year in, year out, except for a thin active layer that forms in the summer and then refreezes in the winter. Now, under the best of conditions, permafrost is a terrible foundation for construction because you have to disturb it to build, and if you disturb it, you lead to thawing of the permafrost. And construction becomes very expensive, and no matter the measures you take to protect the permafrost, it's going to thaw, and your building, your runway, your school, your railway, your pipeline is under threat of some damage. Now, in our new Arctic, which is warming and which we see many signs that permafrost is warming and thawing, this means that construction, new construction, is going to become even greater challenge than it already is. So more expense. So infrastructure building on permafrost is a major issue that has to be considered in this new Arctic should there be a lot of natural resource and other development. There's another issue of concern with respect to thawing permafrost. Right now, tundra soils in the Arctic contain vast amounts of carbon in the form of organic matter, dead plants, probably a few dead animals, but mostly dead plants. And for the moment, that carbon is sort of tied up, it's sequestered, it's seemingly quite securely. But there is a great concern that as the soils thaw and warm up, then microbial activity will increase, and those microorganisms, they're going to consume the organic matter. And in consuming the organic matter, they transform it in part into greenhouse gases like methane and carbon dioxide. These are very potent greenhouse gases. So we have the potential to increase the carbon dioxide burden in the Arctic atmosphere over and above the existing burden of greenhouse gas creation and import from the lower latitudes. So we have the potential through the release of carbon from tundra soils to amplify the effects of greenhouse gases and global warming in the Arctic. That's from the land. Then we have also carbon dioxide and methane sources at the bottom of the ocean. And there is evidence that These gases are being released from the seafloor, certainly in the East Siberian Sea, in Russian waters. There are quite spectacular plumes of greenhouse gases bubbling up from the seafloor through the water column and to the atmosphere. And there is concern that this could increase and again become a significant source of greenhouse gases to the atmosphere, and again amplify the consequences of global warming in the Arctic. And those would feed back to the lower latitudes, as Brendan described earlier, because of the effects on the sea ice cover alone. So there is some good news about permafrost and thawing and the release of greenhouse gases, that currently there is actually no evidence that there has been an increase in greenhouse gas emissions from Arctic sources, from the thawing permafrost on land and thawing permafrost in subsea regions like the East Siberian Shelf. But stay tuned, and this is being monitored quite carefully. There are a number of monitoring stations around the Arctic where these measurements of greenhouse gases are being made on a daily basis. For example, at Barrow in Northwest Alaska, a station operated by NOAA, the National Oceanographic and Atmospheric Administration. The other topic I wanted to talk about is glaciers and the Greenland ice sheet. Glaciers and the Greenland ice sheet, plus the Antarctic ice sheet, of course, they contain a huge amount of fresh water. I forget what the statistics are in terms of the proportion of the global fresh water, but it's a very large amount. The Greenland ice sheet alone contains enough fresh water to increase sea level rise by about 7 meters or 24 feet, should it all melt. Now, the good news there is it's not going to all melt overnight. It would take many years, but we don't have to wait many years for sea level rise to have a significant impact. And this is a significant impact at lower latitudes. There's no question that the melting of the Greenland ice sheet and glaciers in the Canadian Arctic and in Alaska are going to increase sea level rise. And it's the contributions from the Northern Hemisphere glacial masses which are going to increase sea level rise before any contribution from Antarctica. Why worry about sea level rise? Well, at lower latitudes, where most people on the planet live, and a very large proportion of the world's population lives close to the coast, sea level rise is going to affect coastal infrastructure and populations. It's going to affect ports and harbors, naval installations, cities, offices and homes, and so on. So infrastructure and places people live and places people work, things we depend on for commerce. There's also consequences for coastal ecosystems and for salination of coastal aquifers. Fresh water that people depend on is potentially going to become a little salty tasting. So more water treatment perhaps needed, added expense. Now, sea level rise is not constant around our planet. The amount of sea level rise varies around the world for a number of different reasons, which I won't go into. But what is germane for us today here in Washington, D.C., is that the mid-Atlantic coast and the coasts of the northeastern U.S., it's a hot spot for sea level rise. It's one of the hottest spots on the planet. So should sea level rise continue, and it seems as if it will, and even accelerate, we can expect consequences in this region alone. Now, I want you to think back to September of 2012, when Hurricane Sandy was coming out of the Caribbean, and it was heading up the East Coast, but comfortably offshore, causing a bit of rain on the East Coast. And under normal circumstances, it would have been expected to continue to veer, what's that direction? It's eastward towards Europe and soak the British Isles and Western Europe. But instead, it veered a sharp left and it slammed into New Jersey and New York State, New York City. Many people believe that this is a consequence of what Brendan was describing earlier, with the consequences of a warming Arctic, the loss of the sea ice, changing the atmospheric circulation, and the jet stream. And in the case of Hurricane Sandy, that also included a big blocking high pressure over Greenland. And instead of veering over towards Europe, Hurricane Sandy slammed into the northeastern United States. And everyone can probably remember the consequences of that, particularly if you lived in New Jersey and New York City. The reason that that hurricane, Storm Sandy as it became known, as it veered into the northeastern US, was so awful was the storm surge that occurred as it pushed ocean water ashore. This is where sea level rise becomes really important, because people don't worry about sea level alone so much as they worry about coupling sea level rise with storm surges and events like Hurricane Sandy, because it's the storm surge coupled with the higher water level that drives the ocean inland to cause the flooding that we saw in New York City, the inundation of the subway, and the other damage, widespread flooding that we saw, the dislocation and the effect on people. So, just a couple of points then about other aspects of the cryosphere and the consequences of changes in the cryosphere, the permafrost and sea level, as well as the sea ice cover and its consequences. And I'll stop there, and thank you.
Well, Dr. Jeffries, thank you very, very much. A sobering presentation, but thank you. It was extremely helpful. I think for anyone, certainly as I've approached the Arctic, it's hard to get your arms around the science to understand that, the policy implications, the economic implications, and the security implications. But thank you to all three of you, because you've touched on many, many aspects. What I'd like to do is pose several questions to the three of you, and then turn this over to some questions and thoughtful comments from our audience. So I have three questions for each of you, and I think we'll just go down the row in responding to this. So, what keeps you three up at night about the Arctic from your respective positions, from the White House, from the Navy, from the Arctic Research Commission? That's my first question. My second question, and I have to say, as an analyst, I probably spend most of my time debunking myths and misperceptions about the Arctic, the race for resources, and I'd like your thoughts on what you believe is the biggest misperception about the Arctic, and maybe you've touched upon that in your presentation. And my third question to you would be, what should the U.S. government be focusing on today in the Arctic that we aren't focusing on? What are we missing, and what we should be spending more time focusing on? So, Dr. Kelly, I'll start with you, and you can tackle those three questions.
Okay, well, what keeps me up at night? You know, I think the concern that disturbs me the most is our inability to focus on this problem. And this is partly human nature. It's seeming distant. It sounds like bad news. We don't want to think about this. But then we also have people who, for political reasons, are intentionally obscuring and obfuscating what's going on. And we are facing change that is extremely rapid, and we are not preparing fast enough. And I think the biggest lack there is our ability to clearly identify what the problem is and look at it in a sober way. Your second question was?
The biggest misperception.
The biggest misperception. Well, I think it's that it is somehow kind of remote in time and space. And I think that if there's some value in helping people to understand that it really is one ocean, and that you can't put a lot of fresh water that wasn't there into the Arctic Ocean and not expect to see sea level rise around the world, that you can not expect to see climate change driven by the loss of sea ice. So that teleconnection is a big one. And we, I think we, and on the science side, have to bear some responsibility in that some of the shorthands that we use in talking to one another, we then sometimes use when we're talking to the public or to policymakers. And an example would be, it's common for my colleagues and myself to talk about, well, we're moving towards an ice-free Arctic. But as the Admiral pointed out, we're not moving towards an ice-free Arctic in the sense there will be no ice in the Arctic. There will be lots of ice in the winter. The aerial extent, the amount of area covered by sea ice isn't going to change a lot in the winter months. What is going to change is the age of that ice, as he showed, and the thickness of that ice. And that really sets up the condition for summertime. That's when we're going to see greatly diminished areas covered by ice. But even then, the projections are, at least to the end of the century, we will still have some ice in the Arctic Ocean. And that becomes significant if you look at the chart that the Admiral used to show what they project the summertime ice cover will be. There's a shorthand that you might have missed there, which is that it looks like there's ice and non-ice, but what there really is ice that's 15% or more of the area covered, and then there's areas that have less than that. And those areas that have less than 15% coverage, we show as open water. And this has to do with how we monitor and talk about ice. But that creates a misperception that gets very real, because then you get policymakers asking me in 2012 when Shell Oil was trying to drill in the Chukchi Sea, well, I don't understand. How could they be having trouble with ice? I thought the ice was going away. Well, it's not an ice-free Arctic. It's an ice-diminished Arctic, and in the summer months. So that would be another one. And finally, your third question was?
Well, maybe you sort of answered. What should we be focusing on today that we aren't focusing on?
Yeah, I would just go back to that
earlier
earlier one. Yep.
Yeah, perfect. Admiral White?
So the good thing is, Dr. Jeffries and I had time to think about the question. You did? Thanks, Brandon.
Show, didn't it?
Still thinking.
We're still thinking. So what keeps me up at night? Not much. I sleep pretty well. Maybe I don't sleep enough is the reason. But I guess the thing is that we're not going to do enough in the U.S. while the Arctic is still a challenge until there is a crisis. We're not going to be able, I think the U.S. Navy has been out in front, and I think we are out in front. But it's not just a Navy problem. It's not just a Coast Guard problem. It's a national problem. It's not just a research problem. It's not just a science. It's an all of U.S. problem. However, there's only one state that has territory in the Arctic, so a lot of people don't look at it as an all of U.S. problems. I tell a joke sometimes. I say that to the folks on the Gulf Coast where I was born, the Arctic is a continent because that's where Santa Claus lives, so it must be land. To the folks in Boston, the Arctic is something above the kitchen where you store your Christmas goods. But it's really true when you think about it. There's not a broad national ownership of the Arctic yet. So my loose sleep that something bad's going to happen. A horrible destruction of an ecosystem, as was mentioned. A catastrophic event, whether it's a search and rescue with loss of life, whether it's an oil spill because somebody went up there ill-prepared for the type of work they were trying to do, or, God forbid, some type of conflict up there, that we're not going to take it serious enough until it's too late. So that's probably the thing I lose sleep over the most. The misperception, it's exactly what Dr. Kelly said, in that people either think it is a continent or they think it's turning into the Gulf of Mexico. And so they're ready to go up there with their cruise ship or sailboat or their scuba gear, and let's go find, the killer whales or the narwhals or the whatever it is up there. And it's not like that. It's a harsh environment. Even in the best of days, when I'm long dead at the end of this century, the Arctic will be a harsh environment to operate in like nowhere else of a maritime environment. So We can't forget that you've got to be careful. You can't go up there like we do a lot of the other parts of the world. You got to have the ships, the relief supplies, the infrastructure, communications, whatever it may be, because it's a bit different up there. So that's the biggest misperception. What are we missing? What other thing? I think, again, and you said the U.S. government, I don't think it's an all of government. I think there's a part of the government, and I'm not going to throw any certain sector under the bus, although I sort of did in my remarks already. I think it goes back to we may be missing what's going on in the Arctic in all three branches of the government, and we're not taking it seriously enough, that we're missing the opportunities. Great research going on. Navy research, Department of Defense, NOAA research, NASA research, DOE, we're all doing great research. We've got an opportunity through legislative and executive processes working together, God forbid, that we do this right. The Arctic, as I mentioned, we've got time to get it right. So I think that's the opportunity I haven't seen we're addressing yet.
I was just telling Brendan earlier on Metro that I signed up for a Twitter account only yesterday, just to show you how technologically far behind I am. What keeps me awake at night? I think I would say the rate and magnitude of change that's occurring in the Arctic. I first did truly Arctic fieldwork in 1982 when I was doing my PhD research in the high Canadian Arctic on some ice shelves on northern Ellesmere Island, which are now greatly diminished over what they were when I was working on them in 82 through 86. And I remember just a few years ago when a very large iceberg broke off one of these ice shelves, the Wartund ice shelf, and it caused a bit of a stir in the media. And I got a phone call asking, would I be willing to talk about this event? And I was asked, well, if someone had said to you 25 years ago that you would see the ice shelves that you worked on for your PhD diminished to practically nothing, well, my answer was no. I could never have imagined that 30 years ago when I was a PhD student at the University of Calgary. And that's my personal experience, or just one of many personal experiences of the rate and magnitude of the changes that are occurring in the Arctic that keep me awake, because things are happening so much more quickly than we're able to respond in terms of our scientific understanding and scientific knowledge, which can help us make better decisions and make better policy. So, keeping me awake. Then the biggest misconception, I think Brendan and Admiral White have said it well, but let me put it in a slightly different fashion. In mid-December at the American Geophysical Union fall meeting, we had a press conference to release the annual update to the Arctic report card. And we had a panel just like this, there were 4 of us. And one of the panelists, Dr. Howie Epstein from the University of Virginia, he said, and this was widely quoted subsequently in the media, that the Arctic is not like Vegas. What happens in the Arctic doesn't stay in the Arctic. It affects the rest of the world, as Brendan explained with respect to the consequences for the jet stream and outbreaks of Arctic air and other impacts on lower latitude weather, not only in the United States, but in Europe as well. So there is still that misconception that the Arctic is distant, it's cold, dark, it's really not relevant to me. I need not care about it. And we have to overcome some of that refusal to recognize that the Arctic does have an impact, a very broad impact on very many people. And finally, what should the USGS focus on? Well, there's many things, what to choose from. I'll go back to the release of the Arctic report card in San Francisco just a few weeks ago. And I was one of those panelists. And I made a point at the end that for all we know about the Arctic right now, and we do know quite a lot, and of course we have the sea ice observations, we have observations of the melting on the Greenland ice sheet, and various environmental observations, but for all that, we actually have very little data and information about the Arctic. It's one of the most data-sparse regions on our planet, yet it's the most rapidly changing. We should be concerned about that. We need more observations. Why? We need to be able to detect new things happening. We need to be able to monitor and keep track of what is happening. And we need those observations so that we can improve our knowledge and understanding. And through that understanding, we can improve the computer models that Brendan gave some examples of that showed such a widespread and thus uncertainty about, in that case, what's going to happen to the sea ice cover in the future. If we can better project and predict what's going to happen to the sea ice, to the Greenland ice sheet, to permafrost, to ecosystems, then we can make better decisions as managers, better stewardship of our environment. We can make better policy regarding the Arctic and be able to respond better as things continue to change and as potential accidents happen and the need for search and rescue or oil spill cleanup and so on. Thank you.
Thank you all so much. Great answers and a lot of commonality there. I just have one specific question for each of you, and then I promise we will turn this over to our audience. Dr. Kelly, I noted with interest the national strategy, the White House strategy of last May on the Arctic regional strategy. It talked a lot about integrated Arctic management as far as our decision-making processes. And I've been asked many times about that, and quite frankly, I can't articulate what an integrated Arctic management approach, how will that impact policy? How will that change our decision making? So I'd be interested in your reflections on that. And then we hear rumors that the White House will be producing some implementing strategies that will be coming from the regional strategy. I wonder if you could update us on that as well.
Yeah, thank you. I'll start with the latter and say that, you know, your earlier question about, well, what should the U.S. government be doing is actually in that national strategy that the White House released last May. It lays out the administration's view of what needs to happen in the next 5 to 10 years, what our highest priorities are. There is an implementation plan that I expect to be out very, very soon, certainly within a month of now, that describes the implementation of what's in that strategy. The integrated Arctic management concept that you mentioned, which is one of the strategic objectives in the national strategy for the Arctic region, is an idea that's simple in concept and extremely hard to make real. And the simple part of this is that we make natural resource decisions in the Arctic all day long, every day, through lots of different agencies. But we think we can do better in terms of balancing 3 values that are implicit whenever we're making those kinds of decisions. One is the value that we value economic development. Another is that we value protecting the environment. And a third is that we value cultural preservation for the indigenous people that live there, okay? So what integrated would be if we had those 3 values were on a level playing field when we were making resource decisions. And arguably they're not always on an equal playing field. So that's the concept, fairly simple. How do you actually do that? What would it look like? Very, very hard. The report we prepared last year to the President outlined some ways we might approach that. But really what we need to do next is to have a lot of very iterative conversations with the state of Alaska, the indigenous communities, industries, non-governmental organizations, conservation community, et cetera, to say, how do we do this? How do we get those values so they are on this level playing field?
Thank you. That's extraordinarily helpful. Admiral White, with great anticipation, we look forward to the updated roadmap. But I have to tell you, my frustration with the many strategies that have been produced, very thoughtful strategies, they reaffirm many principles that have been our Arctic policy for many, many years. I don't see any of this coming out in budgets. I don't see any of this coming out, sort of showing me that we're putting the strategic thought and we're placing slicing this and prioritizing, you're absolutely right. Hard choices have to be made now to prepare for this great change. Help give us a better sense and what you can share with us on what budgets will start reflecting the growing strategic role of the Arctic.
I would much rather forecast the ice conditions than the budgetary conditions in the future.
We need more science.
But let me first of all say that the last roadmap even drove the U.S. Navy to invest in a lot that sometimes goes unrecognized. One is our research and development programs. And Dr. Jeffries was working with the Office of Naval Research for quite a while and has a lot, but we invested quite a bit of research and development to start to understand the Arctic environment from a naval operative type of perspective, especially the undersea environment. We want to own the undersea environment anywhere that we operate, part of being the away team, if you will, certainly in partnership with our allies, so we can counter threats. God forbid should they happen up there, as I mentioned. So we started to do a lot of research. How does sound behave under the ocean without ice on top and all these kind of things that are changing up there? Doing research on what really happens in an ice environment. How do you forecast ice conditions? The Navy and NOAA partner to have an operational ice center today. Dr. Pablo Clemente Colon works the Navy NOAA Ice Center. In the future, do we go toward an operational ice center that can do more of a predictive analysis of what's going to happen if we ice so we don't have shell oil accidents or things like Antarctica getting stuck in the ice? How do we put that together? So we started to invest research and development toward those two and many other activities. How do we observe what's going on in the Arctic from space or from unmanned vehicles in the future? How do we partner with our allies to put some type of communication infrastructure together to be able, so the cruise ships can do Facebook when they go north of the Arctic Circle, just kidding, of course, but so we can actually have large bandwidth communications for coordination and maritime domain awareness. How do we partner for maritime domain awareness, knowing where exactly a ship is, so if one gets in trouble, we can find it. So if there's somebody up there that we want to know where they are because they might have something that none of us want them to have and they're running around the Arctic, how do we put, so we put a lot of research into that. We've also started to build the policies and procedures to allow us to operationalize that research. The infrastructure of the U.S. Navy, creating a task force on climate change to be able to do that. So now the next step is hard requirements. Based on what we've done with the research, what type of ships, what type of aircrafts, the timing of when you would prepare a ship to get up to the Arctic. And you got to do that. So we've put into place the structure. Now we've got to start to say, okay, and get the owners of our commanders at the Northern Command and the European Command in partnership with allies, who's going to provide what type of capability and what is the U.S. willing to invest in. So we are really getting after that hard decision. So what you're going to see in upcoming budgets is you're going to start to see the wedges to do those kind of things. And that's what our Admiral has asked us to do, make the hard choices right now, put the things in the roadmap they're going to force people's hand. So every 6 months when John White comes to talk to me about what are you investing in, what is the Navy investing in, and the answer better not be, well, we'll wait till next year.
Thank you. Dr. Jeffries, I wonder if you can comment, looking at the international cooperation and scientific research. We know a lot of collaboration is going on amongst the Arctic coastal states, but I wonder if you just from your perspective give us a sense of how closely are we working with our international partners, both Arctic and non-Arctic, on helping to get a better scientific understanding of the changes in the Arctic?
Well, earlier, Admiral White mentioned the Arctic Council of the 8 Arctic states, and it's basically an environmental forum. And so the Arctic Council has many working groups, which are made up of representatives from the different states, and they're all basically pursuing environmental science questions. And so these are great fora for scientific cooperation in the North, but they're not the only examples. I've been in Washington, D.C., working for the government now for 7 years, first at the National Science Foundation, then the Office of Naval Research, and then currently the U.S. Arctic Research Commission. And as time has gone on and I've reflected on what I've been doing and what I've been seeing, it's remarkable how our scientists create the international collaborations, often in spite of governments. And they do a fine job, and we want to do more to encourage that and facilitate that. And another aspect of that I've reflected on is that there is more, perhaps, that we as governments and government agencies working with our partners overseas could do to make it easier for scientists to collaborate, not only in the Arctic but elsewhere in the world, because there are challenges to creating international collaborations with your partners overseas, because different policies exist in different agencies in different countries, and the timing of the availability of money through solicitations and so on, it's not always the same. Trying to align those can be very difficult. And these are the sorts of things that I think we could be thinking about working on in the future across international boundaries to make it a little bit easier for our scientists to do even better in their international collaborative projects. And I think it's worth pointing out that the Interagency Arctic Research Policy 5-year plan and the U.S. National Strategy that Brendan talked a little bit about earlier, both of those documents, they make a point of the importance of international partnerships in science, that we in the United States cannot do it all alone. And it's in everyone's interest that everybody cooperates so we can improve our knowledge and understanding of what's going on in the Arctic.
Wonderful. All right, we have 15, 20 minutes for some good discussion. We have colleagues with microphones. Again, just to reiterate, we are on the record. If you could please raise your hand, and when the microphone is given to you, give us your name and your affiliation. We're going to bundle a few questions, so we want everyone to keep their comments very short and just put those questions out so we can continue the discussion. And I see Caitlin here, please. Thank you.
Caitlin Antrim, Rule of Law Committee for the Ocean. This is primarily for our Navigator of the Navy. I believe there were 22 full transits of the Northwest Passage this year. For most cases, that means the ships will either have passed or will pass along the Alaska coast. How are we in terms of hydrographic information to ensure safe passage? And as we get farther north and GPS is less reliable, what are we doing in terms of other navigational aids to continue to make this a safer place for this increasing traffic off our coast?
We have a question.
I'm Jan Mayers of the Resources for the Future. Two short ones for the Admiral and for Dr. Jeffries. One for the Admiral. The first or second paragraph of the National Arctic Strategy speaks about environmentally responsibly developing the Arctic in an economic way. Should I conclude the fact that you didn't mention much about the offshore aspects, economics, that the Coast Guard is between the two of you in terms of offshore, is more focused on that than the Navy? For Dr. Jeffries, my understanding is there are a lot of methane hydrates in the permafrost, and that there's been worry for years that warming was going to cause those to be released. You didn't mention it. Is that not an issue anymore?
Okay, why don't we take those two questions and let you respond to them? I think you're up, right? You can't hide.
Targeting me.
Pretty fast.
First of all, in terms of navigation, the charts in the Arctic are not the best, not as good as a lot of the world, but then we have a lot of gaps in charting all over the world we could talk about. The hydrographic information along the coast of Alaska is relatively good close in, but the further offshore, the worse it gets. The hydrographic survey responsibility in the U.S. is divided between NOAA Corps, who does hydrographic survey and chart production for the territories and EEZs of the U.S. That is their mission. The U.S. Navy does it for the rest of the world. In the Arctic, we come together, the home team and the away team. So we are updating, we are putting together plans, and it's called out in the DoD strategy that the U.S. Navy, because we are the hydrographic arm of DoD, will work to satisfy the gaps as called out in the National Arctic Strategy. So we understand where those gaps are. The more ice melts, the more we need to understand exactly what's going on. there are other nations who are doing this as well, and we are looking, I am optimistic about some partnerships with all of the Arctic nations and perhaps others to share data and create sort of the type of charting activities we have elsewhere in the world, so we can rely on each other's data to build chart sets to allow us to do that electronically and paper charts if necessary. The problem of GPS is a myth, that GPS is good to the pole for surface navigation. Aeronautical navigation, you run into a few elevation gaps the further north that you go, but the satellite constellation, it's not like our communication satellites where most of us in a geosynchronous or geostationary belt. They are orbiting along the polar type of, it's a mid-range orbit, so you have coverage all the way up to the Arctic, all the way up to the North Pole, and you can navigate safely, as has been proven up there. So that's good to go. North Pole or South Pole. So that's covered. And environmentally responsible, that is especially inside of the EEZ, as I mentioned, it's primarily the Coast Guard's mission, and the Coast Guard has the lead. They're up in the Arctic more than we are today. They're working with our Arctic partners, especially border nations with Canada and Russia, to be able to respond and support the economic interests that are ongoing for the resources that are up there. So they certainly have the lead. In the mission, our part of Homeland Defense, there is overlap, and we work very closely with them, and we'll certainly be doing so in the future. So we're keeping a seaman's eye toward that, as I would tell you, but we're making sure that we are supporting the Coast Guard in their primary mission. Now, as things start to happen more and more in sort of, those zones of the Arctic that are not tied to an exclusive economic zone and those kind of things, we're going to have to take a hard look at that. But right now, I think we're focusing our mind's eye in the right places. If you want to expand on that.
Methane hydrates or gas hydrates, good question. And yes, you're correct. We've known about those for many years, most of all, not least on the Arctic continental shelf, and certainly on the shelf north of Alaska. They've been known for many, many years. And USGS, U.S. Geological Survey, has done numerous surveys and investigations. And methane from those hydrates has been detected passing through the ocean-atmosphere interface north of Alaska, so they are degassing. I didn't name the methane hydrates as such, but I certainly alluded to them, particularly in the context of the East Siberian shelf, where these massive plumes of methane and carbon dioxide have been detected. And while we don't know exactly what the source of those is, are they methane hydrates, or is it organic matter decaying or whatever? In all likelihood, at least some of it surely is from methane hydrates. Yeah.
Further questions? Yes, sir. Oh, wait, just wait for the microphone.
I'm Rafe Pomerantz. My question is for Dr. Jeffries. I think you hit upon maybe the best phrase to tie the Arctic to the rest of the world, at least in the U.S., which is what it's not like Las Vegas. Some of us are struggling to find the key to that for some time, so thank you. I want to ask you, I thought you were going to talk a bit more about the Canadian and Alaskan glaciers in addition to Greenland, because one way I'd like your view of the state of decline. I don't know if that's the right word, because I believe that NASA coordinated a recent study of the fate of the Canadian and Alaskan glaciers that showed a rapid mass loss. And just to go back to the Vegas idea, that maybe the best place to carry that message is to the Southeast United States, or the states that are experiencing serious sea level rise issues now. I don't think most people are aware that the glaciers in the Arctic are a big factor contributing to their fate.
Thank you. My name is Jeanine Nguyen from Voice of Vietnamese Americans. I follow her question regarding the EEZ, and the other day I get the opportunity to ask Senator Lisa Murkowski from Alaska regarding the United Nations Conventions on the Law of the Sea, and she said she's a proponent of it. She felt that it should have been ratified a long time ago. So for your work and for the future of the United States, our sovereignty, our resource, our economy, would you suggest that Congress or the Senate ratify the United Nations Conventions on the Law of the Sea? Thank you.
raise a good point. I did focus on Greenland because it gets so much attention, but certainly the glaciers in Alaska and the Canadian Arctic are very important. And the importance is exemplified by the data that are available on the mass of those glaciers, determined by the GRACE satellite, the Gravity Recovery and Climate Experiment satellite, which in effect literally weighs the glacier masses. And this has been going on since about the year 2000. And when you look at the GRACE record for the Alaska glaciers, particularly those in south central Alaska on the Pacific coastal area, and then those in the Canadian Arctic, the rate of mass loss of those two glacial masses has been greater than the mass loss from the Greenland ice sheet. But the Greenland ice sheet has been catching up in recent years. But certainly it's been shown that of the sea level rise that has occurred over the last few decades, most of it until recently has come from the Canadian and the Alaskan glaciers. But now the contribution from Greenland is catching up and perhaps will soon be larger than the contribution from those glaciers.
Admiral, Dr. Floyd, do you want to talk about UNCLOS a little bit from your respective agencies?
Yeah, I'll just say that the national strategy for the Arctic region calls for, it's not ratification, what's the technical term here for, what is it? Well, accession, thank you, to the convention. But that's not new. That's been this administration's policy. It was the last 3 administration policies. And I'm wishing the senator good luck in making that happen.
And similar, the U.S. Navy leadership, Secretariat and Chief Naval Operations have voiced strong support for this session to UNCLOS, as had our Secretary of Defenses, many in a row, and Chairman of the Joint Chiefs of Staff. So the military and DOD is well aligned toward do that. Personally, John White speaking, it's hard for me to manage. It's hard for me to imagine us taking leadership of the Arctic Council again. A body that's actually based on UNCLOS as a structure without sitting to UNCLOS. I won't say it's like driving on the Beltway without a driver's license, but it sort of reminds me of that a little bit. So, personal opinion.
We've talked a little bit about international partnership and collaborating with other countries. And I think the issue of UNCLOS in the Arctic Ocean is a very good example of that. The US, Canada, and Denmark have been collaborating in mapping the seafloor to create the documents they need to submit their claims. And here's 3 nations which have conflicts over boundaries in the Arctic, yet they're collaborating in mapping the seafloor to determine those boundaries once and for all for international peace and security.
It is a great point to end on. I think some of the important themes that came out of our discussion, and certainly the Q&A, the United States is not preparing fast enough. We're not creating national ownership of this issue. By preparing now, we can ensure a strong capabilities response and hopefully strong science that can help us understand these profound and stunning changes. I'd like to thank all 3 of you, and I stand the outstanding intellects were on full display in the last hour and a half. Thank you for helping us understand a complex issue, understanding what's important. We're so very grateful to you, and of course, we're very grateful to UNEP. Elizabeth, Bill, thank you for your partnership. This is an important conversation. I noted 2 important conversations. We have a month or so of an implementing strategy. Less. Hopefully less coming out, so something to talk about. And Admiral White, all eyes are on the updated roadmap when it is out. So
yeah, we're racing.
We're racing? Okay. It's a race I like. I'm going to analyze both. And we thank you again for visiting us on this very cold Arctic day. Have a great evening. Thank you all so much.